Good morning, everyone, or good afternoon, or good evening, wherever this video might happen to find you. Today I'll be sharing findings from our study related to AI in space scenarios. We actually began by exploring how humans and AI interact in isolation, let's say situations with no communications capability, where astronauts might depend entirely on offline AI systems for decision support. As the study evolved, we realized that these interactions reveal broader implications for a proper astronaut training. So this led to the work title here, Evaluating Offline AI Assistance in Analog Missions, Implication for Astronaut Training, and Their Operational Readiness. This research looks at how astronauts engage with locally hosted AI. The kind they might rely on when in isolation, or let's say signal delays that just makes access to cloud-based AI quite impossible. A little bit about my background. I spent several years working as a software engineer, focusing on large-scale full-stack design systems. But over time, I shifted my focus towards artificial intelligence and robotics, and I'm pursuing a master's in Georgia Tech in that field, AI and robotics. And my current work actually centers on AI for space operation, studying how astronauts can use AI safely and effectively, I guess, in both analog and isolated environments. And recently, I participated in one of the missions, in Mission 103, and it reveals some fascinating insights, especially on how the crew builds trust and how the crew works alongside AI, which, as you will see towards the end of this presentation, makes the following quote pretty accurate. Like in this deep space, the most reliable system may not be the smartest machine, but it will be the human who knows when and how to question it. Essentially, tools are getting pretty smart, but it boils down on how and effectively you can use it and understand it. So let's begin. So, as astronauts move toward long-duration lunar and Martian mission, they'll increasingly rely on AI assistants that function without any connection to Earth. Think about it. Many people today are getting used to interacting with cloud-based AI systems that are fast, robust, and finally corrected by enormous online infrastructure. But offline AI is very different. For instance, local hosted models have no external safeguards, no continuous context memory, no hidden human moderation. They just require the crew to properly think about and carefully think about how they prompt, how they verify the answers, and how they recover from any context errors. So let's say assuming that astronauts train on ChatGPT-like system who seamlessly just operate an offline model in a habitat might be a false sense of readiness. These tools demand new skills, part psychology, part engineering, part verification discipline. And despite these challenges, the payoff is enormous. Even in this analog mission I was part of, we saw how local AI expanded the crew's capability, just helping them troubleshoot systems, plan procedures, and just create safety checklists. If used wisely, the AI doesn't replace the human skill but amplifies it. But the question is, how do we train humans to use this assistant effectively and most importantly, safely in isolations and for critical scenarios? So for the experiment setup, this study was conducted inside Astraea's 103 analog mission at the Analog Astronaut Training Center in Poland, where crews live and work in isolation to simulate off-Earth operations. And during the mission, we deployed three locally hosted AI, each running entirely offline with no external connectivity, and you can see them up on the screen. The first one, Gemma 3, is a compact 4 billion parameter model that responds quite quickly and feels conversational. The second one is more in the middle ground. Llama 3.1 with 8 billion parameters is fast enough for dialogue, but capable of even more structural reasoning. And then the last one, DeepSeek R1 is 14 billion parameters and is the largest and most resource intensive of the three. And yet it produces the most methodically explanations whenever prompted. So this system will run directly on local hardware under realistic power and compute limits, especially during blackout scenarios. And to evaluate human interaction, we use three tools. And the first one you might have heard of before is NASA TLX, which is to measure mental workload and frustration when performing tasks. The system usability scale for perceived ease of use or how difficult the crew members found the usage of these AIs. And finally, trusting automation items to capture the confidence and how much crew rely on these AIs. And altogether, the crew members completed four tasks, and we gathered about 20 data points, and we were able to compare both quantitative matrix with behavioral tendency across the different AI assistants. So, to simulate realistic time-bound mission condition, each crew members completed four concise operational tasks that try to simulate or mirror daily analog activities. And one of them, for instance, was the CO2 sensor anomaly diagnosis, where participants asked the AI to propose possible causes and a quick checklist of what to look out for in this scenario. Another task, as you can see in the screen, involved identifying the first step to restart the air recycling unit and see how the model interprets procedure style prompts, right? One of them was the pre-sleep safety checklist, asking the AI to create a checklist, a concise 5 items, an excellent way to see how the AI can summarize and produce like a specific checklist without breaking trust. And finally, task 4, each participant was asked to select their favorite AI. And was used to generate a three-step guide for storing experimental samples safely. This was like a test to reveal the preference pattern in each crew member and see how their trust and previous interaction with the AI transferred to this last task and the usage of this AI, which the crew had no idea what AI they were picking. They just said, I like AI 1, AI 2, or AI 3, and I want to use it for this last task. Well, each task was allowed 2 to 10 AI exchanges. Participants could stop early if the goal was achieved, or let's say if the AI was becoming too repetitive or totally unhelpful. And it mimics the real decision workflow in isolation. And after each task, they completed the three items, NASA TLX, SUS, and the trust in automation. And well, the researchers were evaluating qualitative and asking questions how the process was going. And of course, a final debrief followed, where participants reflected on which AI they trusted the most, what behaviors they value, and how this experience might shape astronaut training needs. And the preference on their fourth task, AI. So across these roughly 20 data points, we see a very human story about AI interactions. There's four takeaways from this. The first one is like concisiveness is really important in improved performance. Like when AIs produce concise checklist style answers, especially in pre-sleep safety check, participants reported lower mental demand, effort, and frustration on the NASA TLX scale. And those tasks typically score between 1 and 3 out of 7 across workload dimensions. But in contrast, let's say, when models generate these long, meandering explanations, particularly during the area cycle and restart procedure, temporal demand spiked, with values reaching up to 8 or 9, and subjective performance dropped. Then the other clear pattern was a speed versus trust curve. So as it was expecting in the hypothesis model, Gamma 3 smaller model was the quickest, producing friendly, low friction answers and yielding the lowest workflow. But it actually, for some crew members, it resulted in low trust. Llama 3.1 with 8 billion struck the best balance. It was a moderate mental demand, but it has the highest system usability scores. So it reflected clarity and precision while not interrupting the astronauts or the crew members from asking questions. Now, DeepSeek 3.1 with the 14 billion parameters require patience, and this is where the temporal demand spiked the highest. Uh, but surprisingly, scored more on trust and dependability, showing that if participants were willing to tolerate latency, the accuracy did feel higher. And the other element is like even though whenever there was mistakes and there was trust erosion, it was just temporary. Like a model confused aircraft for spacecraft, and trust ratings dropped because the crew member just felt it was not understanding. But a quick change of explanations, a context explanation, and good prompting quickly corrected and restored confidence. And yeah, I guess the most important thing is we found a strong association between prompting feels easier and lower workload, clearly indicating that a promptability is quantifiable and should become a future astronaut training metric. So while the quantitative results gave us overall patterns, especially that promptability can be measured and should be a metric tracked when training astronauts, actually the most interesting insights came from how differently each crew member interacted with the same AI. And honestly, a surprising thing uh, was the hypothesis was modeled llama with 8 billion parameters. The middle ground was going to be the most preferred and used by both of the members in the crew, but it didn't happen to be that way. Um, so actually, each crew member preferred a different AI, and we can see like three archetypes emerge from the crew behavior. Probably in a bigger study, we can see more archetypes, but it indicates that personality of the astronaut and the knowledge of the AI actually influence what preference they have. The first archetype is what I call the pragmatist operator. So he consistently preferred the Llama 3.1 model, and this archetype just wanted the AI to be fast, direct, and clear. Long reason chains or sentence answers were just frustrating, and often said things like, "Just give me the checklist, I can move on." And for this operator, trust was built through clarity and responsiveness, the sense that the AI was supporting his momentum, not slowing him down. So this behavior mirrors how some mission operators under stress prefer systems that give simple, actionable outputs rather than just long explanation. And now, an interesting one is the second archetype, which I call the companion user. This action operator chose the smallest model, Gemma 3, not because it was the most capable, but because it felt the most human. The operator appreciated the friendliness, the conversational tone, and the sense of interaction. Think about it. In isolation, this actually it's an asset from this model, which in my hypothesis we didn't consider. But after 7 days of isolation, things like friendliness and sense of human touch actually might help the crew member follow through or prefer specific AI. And even when the AI made small mistake, Still described as trustworthy just because it was easy to talk and didn't feel robotic. And this just indicates that in isolation, it might be necessary to establish empathy and human connection with an operator. But it reveals the problem that with the empathy bias, it might be a critical operational risk. Think about it. Friendliness from, let's say, this AI that's like less accurate than the other AIs. Friendliness can mask subtle inaccuracy, especially if the AI is not prompted correctly. And like in a real mission, this kind of overtrust could lead to dangerous oversights. And finally, we have the third archetype, which we saw that was analytically specialist, who gravitated towards DeepSeek 3.1. DeepSeek 3.1 was quite a slow model, and it took a long to reply. And also, you can see its thinking process. You can see the thinking process while still waiting for an answer, and then it was a long wait answer. Um, but this operator said that whenever he uses an AI, it means I don't know the information, so I want to see its thinking process because I know this is critical because I don't know it. For the operator, the speed was irrelevant. Like verifiable reasoning equal trust. So rather wait long for a correct answer, transparent answer, than get just a fast but shallow one. You see, just a simple experiment. We have three archetypes and show that trust is not universal in AI. There's something for the personality of the crew members and also the context in which it's used varies the preference of the AI and the effectiveness of the AI. So it's up to the astronaut training that must adapt to this diversity and understand this diversity and where it comes from based on how strong a model is or how powerful a model is or how biased or friendliness a model is. If we combine both this quantitative and qualitative results, we actually get various insights. Now, from the operational perspective, several patterns stand out that go far beyond the human factor, and they directly inform how the crew should be trained to interact with AI and be operational ready. For instance, one of the things we observe, right, is the checklist style prompting consistently reduce workload. So in other words, when the AI frame its responses as short, order actions, mental demand just dropped, frustration dropped dramatically. So it wasn't just that it was faster to read, but it was easier to trust. In other words, brevity is not just aesthetic, it's cognitive efficient, and crew members perform better subjectively. Second, we observe that trust erosion is not permanent. So let's say, for instance, one of the tasks, a model confused aircraft for spacecraft, and it caused the trust to dip sharply. But once the crew member caught it and corrected it and gave context, confidence rebounded within minutes. So this is very important observation for like local AIs that might not be as smart as a cloud AI. It means that if context is quite accurate, but also the crew member is verifying the data, it can actually correct incorrect outputs from an AI and trust can be rebuilt. So both the model being able to acknowledge errors transparently, but also the astronaut being able to catch those errors are essential. Finally, we observed that latency tolerance scale with competence perception. So that means participants were like far more patient when the AI seems to think intelligently. So Lipstick, despite being slow, was forgiven most of the time because it was like, well, you're giving me a reason in depth and you give me a really accurate answer. But we have the other side of this coin, the friendliness bias that we call. Um, Human-like tone increases emotional trust even where accuracy slips. But think about it. This kind of misplaced trust could become dangerous if friendliness masks subtle hallucination. So, encompassing these three items, we just learned a critical lesson that prompting skill is an operational skill. Prompting skill is a mission skill. Like using offline AI effectively is not just about asking the questions. It's about knowing how to structure prompts. How do you want your answers delivered? How to cross-check results to correct any errors and detecting consistencies. And finally, giving your style. Like if you prefer a slower or more thought response, or maybe a faster but more friendly response. Um, so in essence, it means that AI literacy, sorry, is an optional. It's just as essential as EVA training or procedure memorization. Astronauts will have to train on what makes AI works, how the model works, and all these prompting skills. Prompting again is a mission, seems like to be a mission skill that needs to be trained. And yes, just take the results. They clearly show that AI literacy must not be treated just as another technical curiosity, but it's actually an operational skill. That will be the recommendation. Today, many astronauts and analog crew, yes, they know how to use cloud-based AI. A fast, capable system that compensates for any poor prompts or missing context, but in an offline system, an online mission, there are no hidden guardrails, no internet connection loops, no data pipelines maintaining consistency. So that means the crews must be trained to understand the limitations of local AI, slower reasoning, narrower context, and a higher chance of hallucination. In essence, they need to know how to help the AI help them. And that's just through proper prompting, good structured queries, specific context, continuous verification. That's a key Recommendation from Asterias 103 results. The prompting is just not a convenient skill, but an operational safeguard. The ability to reprompt effectively, recognize when an AI is drifting, validate reasoning, can make the difference between a correct decision and a dangerous one. And to operationalize this, it could be in analog or astronaut training, we can have trust calibration drills, exercises where AI intentionally makes mistakes and see if the crew detects them and corrects them, cross-checking routines where different members with different AIs cross-check and validate data, and simply have prompting in AI workshops. Because in essence, it is simply that astronauts don't just need to use AI, but they need to understand the underlying principles and what they're doing with them. Looking ahead, it's clear that AI is here to stay and advancing faster than any of us can keep up. With a few years, we'll see advancements in models. We have dedicated onboard hardware, real-time accelerators running inside spacecrafts and habitats. We'll have retrieval augmented systems that can access procedure databases. We have all this technology, but in the end, we will always need the complement of good AI literacy. So one truth will remain in our recommendation is that human readiness determines mission safety, and even with the most advanced models, astronauts will still need to understand how the systems think, where they fail, and how to verify their answer. This training can carry to like whatever technology leaps AI will be making in the future years. And there's so many studies to make out of this. There could be expansion of my current studies, but there's so many fields like psychology, statistics, and even other software engineers called computer science can jump in and use analog missions as a testbed for human and AI interactions because understanding this will be crucial for the years and the decades to come. This is the cornerstone technology to improve productivity of a crew. So it's quite the essential matter that we learn how can must be specialized to understand it properly and use it carefully and adequately to keep the mission safe while completing tasks. To wrap up, we have this coming up again. Uh, Now with more context from all the presentation. Deep space, the most reliable system may not be the smartest machine, but the human who knows when and how to question it. We'll have a potentially very smart and very powerful tool, but it's up to us to be ready to use it properly and to keep our analog missions, our future space missions, and the crews and the lives of those who venture into space safe. And it all starts with training, operational readiness, all this new technology, being understanding what we're using, how can it be used.